Let's okay. This overall, he has given the information like this much. Okay, get into the calculation part. This is a liquid. It is filled with a liquid of refractive index mu, and this is some made up of some material, glass. I'll take it out this diagram. Okay, now you have clear diagram. I read the question. Think on it. So something polarization, Brewster's angle, what we discussed, no, something related to that it is. The idea of Brewster's angle that you have to apply here. Okay, shall we go like this? So let the angle of incidence here be theta 1, theta 2. Here let it be theta 3. Or Brewster's angle, I'll put it. Or polarizing angle. Any of the symbols. So what is the question is, it never completely polarized for this to happen. So it should not get completely polarized means the light reflected from the liquid glass interface is never, it should not get linearly polarized, means partially polarized it should happen. For that to happen, what should be the light, you know? It should not be equal to, this incident angle should not be equal to Brewster's angle. I think problem solved. If this angle, the angle theta 3, I think it's better to make theta 3. I'll be the theta 3, theta. If theta 3 is not equal to Brewster's angle, then this unpolarized light. So here also some light will be reflected, what will be that one? So here it will come here. Now the reflected light from this glass surface water pen will be partially polarized here. I think yesterday we had discussed the concept. That is what is asking as a numerical. So this is what actually what we, in a book, what we have, if the light is incident at polarizing angle, then unpolarized light when it is incident at Brewster's angle or polarizing angle, then the reflected will be reflected will be linearly polarized. If it is not at polarizing angle, then the reflected light will be partially polarized. So theta 3 should not be equal to Brewster's angle. For that, what should be the value of mu? So first we'll go for the critical angle condition. Where the critical angle it should come, a student find that irrespective of what the incident angle I. Oh, he has given symbol. Huh? Let me take I. Theta, I'll write it. Let me write this is alpha. Yeah. Let me use the symbols what he has given. How to proceed? What is the meaning of this? Something. So let me go for critical angle condition. So it is moving from liquid to this one. So if they should not undergo TIR, sin C equal to 1 by mu, 2 by mu, I can go for it, no? Irrespective of what the incident angle I is for a beam of light. So what is the maximum permitted value of I? 90 degree. If it is 90 degree, then it should be the grazing incidence. Then this light should undergo, there should be equal to critical angle. Am I right? I think the way he has asked question, from that I'm going for like this. This is I. So the wave is here. So when this is air, this is mu. So what is the formula? 1 into sin I equal to mu into sin R. When I tends to 90 degrees, R will become critical angle. Sin 90 degree equal to mu sin C. Sin C is equal to 1 by mu. And this is 1, this is mu. So this should be equal to how much? 1 minus mu square. Keep it in this way here. Now let's come for this one. What is the Brewsters angle formula? It should be mu g by mu.
Sir, it should be root of mu square minus 1, sir.
Mu square minus 1. No? Okay, hypotenuse is mu, no? Yeah, fine. What is the Brewsters angle? Tan theta polarizing angle should be equal to mu g by mu, 2 by mu. Any condition shall we put it here? The critical angle on one side. Any condition between C and polarizing angle. I want students to think this one here. Should be equal, should be greater, should be less than. So that here partially polarized light I should get. Then this should not be equal to Brewsters angle. Am I right? So this theta equal to alpha only again. This is again equal to C only. This angle of incidence should not be equal to Brewsters angle. Should not be equal to this one. So, but is it any justified mathematically what it should be? Less than or greater than? It should not be equal, I'm very sure. I'll go for less than. So tan, like C it is there. So let me take tan C is equal to tan theta B, because tan theta B value I know it. 2 by mu. Tan C, I'll write it as 1 by mu square minus 1. Somebody should simplify. I don't have. I think we can square it, no? Mu should be less than 2 under root of mu square minus 1. Mu square should be less than 4 mu square minus 4. So this mu should be greater than 3 by 2. Or okay, I'm bringing some answer like this. So what is the meaning of, say, like we are not understood this? why you are writing. Okay, this is okay, fine. This is the thing. And this is the Brewster's angle. The angle of incidence alpha should not be equal to Brewster's angle. So why don't you write greater? Why only less? Anybody wants to justify it? For the any angle of incidence is telling, no? Yeah. What is the maximum permitted value of I? 89.99 degrees. At that point, this will become equal to critical angle. So no question of further that angle making more than C, no? See, greater is nowhere available here. Because as I increase this I 89.99 degrees, then only this will become critical angle. So I cannot make greater than. So what is the only possibility is less than. Able to analyze, just simple. You have to look at this particular aspect here. When this will be called critical angle, when this is 89.99 degrees. So can I go for beyond the value of C? So therefore the critical angle which is there, if it is less than polarizing angle, then this will be partially polarized, will not be like a linearly polarized. That's why I took less than here.
Sir, mu equal 2 by root 3, sir.
Mu